Okay, so the title of my presentation is "Can a public cloud process private data?" And by public here, I mean AWS. I'm not going to talk about any other cloud provider, so that's one thing off. Short bio, if someone doesn't know me, I'm working in IDEMIA since 2015, and before that in AMG.net in Poland, so I have at least 20 years of experience, professional experience. I've been mostly writing, designing code for this time. What I like, you can read, and what I dislike is actually I forced myself to find out what it was, and I found out that what I dislike the most is the bloat of a form without a content. So, overblown form is never good, and this is actually probably one of the properties of anything, including code. And this spurs accountability, responsibility. I believe in structure. I believe in hierarchy. I don't believe in some kind of flat structures. I believe that you have to have a responsibility and accountability to perform. So, no, I don't believe in flat structures. And I don't like complaining. I prefer to do stuff. So if you have a problem, don't ask me about the problems. Ask me about the solutions. Those I find most interesting. I'm married. I have 3 children. So that's it. Main questions that we'll try to answer today are about if and how process confidential or sensitive data in a public cloud, and how to process those data in cloud applications, and which AWS services are most commonly used, most helpful to do that. And this will be based on my experience with SRC project that we have done and we have deployed on AWS. The knowledge presented doesn't necessarily, all of the techniques that I'm presenting were used in SRC for the simple reason that not all of them were available at the time, and not all of them were really required. I'm also not an AWS certified expert, so excuse me if I do any mistakes or put some wrong information. You can cross-check me and check if I was correct or not. Applying any of those advices will not guarantee the security of a system. The security is a complex topic, and it's typically very many layers of security that has to be in a system. So no single technique will save you, basically. The agenda, well, we'll start with a short refresher on theory. I hope it will be a good one for you. And how to manage keys, cryptographic keys in AWS, and then how to protect confidential and sensitive data in AWS. So in order to, let's say, pinpoint a discussion, we need to first define what is this confidential data. And, typically, if you are talking about the security, you have to somehow categorize, qualify what you are talking about in terms of what type of data that you are using. And typically, if you put the confidential data or confidentiality classification into the Google, you will get something like this, that there are 4 categories of levels of confidentiality. The first one is public. So there is basically open to anyone. The internal is inside your system. It will not be typically available to everyone, except for the logged in users, for instance. You have to access the system first and have to somehow gain the access. The confidential is probably the level where you have to protect your data, and you have to make sure that this data doesn't leak out and it has some intrinsic value, and sensitive, that it's of a most critical, let's say, that's most critical level of confidentiality, and that's of the utmost important. If that leaks out, you're probably going to lose money or customers or both. So obviously there is a spectrum, and it depends actually on the other things. I will mention that later. But first principle of the processing of sensitive data is a funny one: don't. If you don't have to or cannot, basically, don't process sensitive data. And this is what GDPR, this is for Polish folks, it's RODO, tells us that you don't process sensitive data unless you have to, in a sense that you are entitled to do that. You have the right to process the sensitive data. If you don't have the right to process sensitive data, don't try to process it. And how to classify specific data, that will be domain, region, law specific, and it will basically be a topic that it's outside of this presentation, and I will just use an example that I know at least two of them. The first one is GDPR, so it's a personal data perspective, and we have the confidential data that we have to protect by default, and every time this is data that can be attributed to an individual, a person, a human, name and surname, address, any kind of a national personal identifiers, tax identifiers, social security numbers, phone numbers, IP addresses, HTTP cookies, anything that you can trace back and attribute to a single individual. So if I can, for instance, find out who that person was by narrowing a couple of perspectives, like I know the zip code, I know the street name, and I know that this person is a male and he has an iPhone and he has an interest in cars. So probably by narrowing all of those information, I can go and identify a single individual. And by that, it means that all of this information is really personal data. Even if by a look at it, it's not. I mean, the zip code, why? The address, why? But if you get all of the data together, it will be confidential. So this is GDPR. US has a similar, they have a concept of the PII, personally identifiable information, but there is also a sensitive level on the GDPR, and that don't process at all unless you can. You're entitled to. You are a company, an institution, an organization that is entitled to process that kind of data, like biometric, health-related data, financial data. But generally speaking, you should not ever process the things like political biases, religious beliefs, or sexual preferences of users of your system. For the PCI DSS, that's the domain that I'm part of. We have a similar, let's say, classification for the confidential cardholder data. We have a name and surname, card number, card expiry date, so-called service code. This is what the PCI DSS specifies. And we also have a sensitive authentication data that should not be processed. And if they are processed, that should be really taken care of. And they should never be stored in your system, for an example, outside of the actual transaction. And after that, it should be cleared. And you have to control that part of the processing because it's sensitive, as the name implies. I haven't put any kind of a cryptographic keys here, since PCI DSS basically doesn't cover any kind of a processing of the payment keys, cryptographic keys for the actual payment. It's outside. You cannot do it in PCI DSS. You have to do it under other compliances, like CP or token. So the compliance, the certification, the law is a driving factor for your data security. You have to first understand it and learn how to apply it, or take a course in it. And the AWS services typically have their attributed compliancy level or certification that they were able to pass on their own. It doesn't guarantee that your system, even if you use just the AWS services that were certified for your particular, for instance, PCI DSS certification, it doesn't guarantee that your system will pass the certification, but there is a so-called shared model. So when you are developing a system, a part of the responsibility is on the AWS, and the part of the responsibility is on your side to correctly design the system, correctly protect the data. So that's one thing to remember. Now, quick refresher about the so-called security of information model. We have it is being shown as a triangle, where there are vertices of this triangle are confidentiality, integrity, and availability, for short CIA. I identify typically a separate aspect that is not taken care of by this triangle. It's non-repudiation or the authenticity of the data. So you have to be sometimes sure that this data comes from the trusted party, that it's actually this data has never been modified. And that's a part of the integrity, but also it can be also addressed by the concept of non-repudiation, that you basically, the other person cannot deny, or the other system cannot deny that they have made such a request. And this is also realized through different techniques that are mentioned here on the slide. So for the data confidentiality, we are at the top of the triangle. We typically use a couple of techniques. Simple one is masking. So This is actually my personal phone number. I haven't revealed the rest of it, so you don't know what it is. I kind of protected myself. But the other technique would be the obfuscation, and this is typically a hash function, sometimes a truncated hash function to make collisions, let's say, more frequent, therefore avoid identification of the phone number. So it's a one-way function. So if someone knows my phone number, they would be able to compute a hash and say, okay, this one was really there in the logs, for instance, or in the database. But just looking at the hash, they would have to brute force me. So one obvious thing is to not to combine masking and obfuscation, since that improves a chance of an attacker to find, let's say, in this case, a phone number. And the ciphering is obviously the most, let's say, heavyweight technique. Still pretty good. And there is another technique that we are using frequently. It's called tokenization. It's basically replacing this phone number with another phone number that I can safely give it to you. And it will basically redirect to my phone number, but still the original data is protected, and that's the idea. So what's the difference between ciphering and tokenization if you look at it from a perspective of data security? So you have a data, you have a key, and you cipher this data with a key, and you obtain a cryptogram. That's sure, and you can decipher it. So in the tokenization, it's similar. You have some protected assets, some data, some card, for instance, payment card. You have a token vault, and you tokenize, which means that you put this data into the token vault, and you obtain a token, which is this public phone number that I presented on the previous slide, and then you can de-tokenize. So if you compare those two, excuse me, two pictures, there is no substantial difference, and you can say that the token vault is really a key. And for that matter, the token vault is a key, and the tokenization is a security cipher, basically, that ciphers the data using the database. And actually, in the cryptographic, let's say, nomenclature, it has a name. It's a so-called one-time pad. If one is interested in that, you can look it up. It takes a little bit of time to wrap your head around the concept, but it's, as you can see, at least, it's similar on the picture. The other aspect, the second, let's say, vertex of a triangle, it's a data integrity. And typically, when we have a database or kind of a structure, and we have something that we have to protect, like discard data, typically what we do is just put a lock on it. But in this case, it's a signature. It's kind of a check using the checksum using the MASEQ algorithm, so it's message authentication code, or some kind of a hash algorithm with some security inside it. But what is typically being missed, and we have systems that are actually not doing that correctly, is that you can take this card and assign it to a different user, and there will be no checksum that is invalid here. So the RAUG database administrator or a person that has an access to this database can replace the foreign key, let's say, or a reference in a card record to point to a different user or a association database if this association is not part of the signature or part of the checksum. Therefore, what we shall do, and what is being typically missed, is that the associations, any kind of reference, linking between the data items, linking between data identities, shall also be taken as part of the should be taken care of as a part of data integrity. So this is a correct approach. Now, those two things, both confidentiality and integrity, require typically a separate cryptographic algorithm. So we have to have a separate keys, separately manage that. There is a problem how to wrap one into another. Should the integrity comes first or the encryption come first? And there are, let's say, different techniques. But one of the solutions that we have been using in SRC and a couple of other systems for quite a long time now is to use just so-called authenticated encryption scheme, which basically means that those two aspects, which is a confidentiality, which ciphers the data, and the integrity, is combined into a single cryptographic algorithm. And I would say that in AWS, when you use any kind of a service, that this one will be the one that you will be using the most. This one is, let's say, ubiquitous. And, well, there is nothing more to tell except for this fact that authorization tag is basically incorporating the plain text in such a way that it will verify if this cryptogram was correct or not, if anything was done here with the ciphertext. But it also incorporates the so-called additional encryption data, which is typically forgotten. And in this additional authentication data, you can put something that I was trying to divert your attention to, which is those associations. They don't have to be ciphered. They just need to be integrity protected. So if you put them into your additional authentication data, the algorithm will make sure that any kind of associated data that is connected to your confidential data will also get correct integrity protection and will be included into authorization tags. So the situation where this switch would happen would be detected by the fact that from looking at the database, the associated data with this card would be this user, and that would not match this authentication tag, and you would detect that situation, even if your associations in your database are not ciphered, basically. They are only integrity protected. Now, we have obviously keys, and we have to somehow manage them. And in the cloud, typically the question arises how to do that. Where should I store my keys? I have keys, where I put them? Should I use and go directly for HSM? Because this is what we typically do in our, let's say, private clouds. We use HSMs. Now, maybe there is a better way how to do it. And the key management itself must satisfy a CIA triangle. So you have to make sure that the key is confidential, it's integrity protected, and that it's available. So how to do that? So AWS offers a service that is called AWS KMS, and it's a central piece for all of the security of this platform, I guess, at least by looking at how many services other AWS ones are using the AWS KMS. So when you talk about AWS, you typically concentrate on EC2, you concentrate on S3, sometimes you talk about DynamoDB, then you go to the Route 53. But what is really fueling the security here? So what is the, let's say, the underlying security mechanism? So the idea is that you have the AWS KMS, which is backed by the HSM. And what you store there are so-called customer master keys. So those are not the actual, let's say, data keys, and there is a distinction that are going to protect your data. So imagine that this data key ciphers the data. So this data key needs to be somehow managed, protected, integrity protected, available, and so on and so forth. The idea is that you put a CMK into the KMS, and that CMK typically wraps your data key. So you create a hierarchy of keys where CMK ciphers your data key, and your data key ciphers the data. So what about the CMK? So it wraps the data keys. It can be symmetric or asymmetric. It's region dependent. Some regions do not offer this capability. You can bring your own key. So if you already have an HSM infrastructure in your private cloud or basically data center, you can extract those master keys and put them directly into a KMS, or you can ask KMS to generate, which is the preferred technique, and you should do that because otherwise some of the features of the KMS will not be available, like auto rotation, for instance. It can be replicated between regions, and this is thanks to, I don't know if Marek can on the, no. It's thanks to him and part of his team that they requested this feature from AWS, and it was delivered. Unfortunately, it was delivered after SRC system was deployed into production, so we haven't got to use it, and we always targeted for multi-region, therefore we had to design the system without this feature. Unfortunate, but it happens. You can cipher small blocks of data, and important, this can be only then deciphered by KMS. So if you cipher something with CMK, it doesn't have to be a key, it's your choice, but then you cannot count on it that you will be able to decipher it on your own. So therefore, it's the kind of wrapping that's intrinsic to KMS, and all it does say is that it's underneath, it's using some kind of a symmetric or asymmetric algorithm, but you will not have a lot of influence over that, and you will not be able to decipher it by yourself, most probably, because this is not published thing. At least I wasn't able to find the algorithm. It can be automatically transparently rotated. So the transparent rotation, so how does the CMK can be rotated? And all of your data keys will be then invalid, right? And how does the KMS will recipher your data? No, it won't. Basically how it works is that CMK is an entity that can be, underneath there is a key material, and the key material gets rotated, but the identity of CMK doesn't change. And the idea is that once you have multiple versions of your CMK keys that have been rotated over the months, years, decades, most probably, then each and every new data piece, each and every new data key that you are going to cipher with the CM key will be ciphered with the most recent active version of that key, but the previous version of your CMK will be available to decipher the data. And therefore, in this wrapping of a data key, there is a version of the CMK being written, so that when you unwrap this data key using the KMS, it automatically knows which version it was used to wrap. So therefore, it works transparently. Obviously, the KMS has its own security module, hardware one. We are not being told what it is. We know that it's just FIPS certified level 2, and in some areas level 3. But you can also, if you are so inclined, or you have actually other requirements to use HSMs in your project due to the compliance and certification requirements, you can use the Cloud HSM, which I'm going to talk about a little bit later, and as a custom key store. So therefore, the CMKs doesn't have to be stored in the, let's say, KMS-specific private HSM. It can be in your, let's say, managed Cloud HSM instance, actually a cluster. And the CMK generated, which is the recommended technique, cannot be extracted out of the KMS, which is a good thing, because then you can say, okay, it has been generated by AWS. For sure, it's secure there. And I'm pretty sure it's secure because you cannot extract it, right? And so it's a feature. But if you bring your own key, obviously that's a different story, right? And as I mentioned, it's certified on a FIPS level 2, and is level 3 in some cases. That's probably going to improve or change in the future. The AWS typically improves the situation over the time. Now for the data keys, what about them? Well, you have to use them to protect the application data, that's for sure. You can bring your own or generate securely in KMS. KMS does offer a function, and that's against the best practice to use the feature of generation, the data keys in KMS, because there is a FIPS certified security model that has a proper entropy and has a proper generation of random keys. You can store those keys ciphered with the KMS CMK, so wrapped in a database or a file. That's the a technique that you should use. You can use any crypto algorithm, because as far as the CMK is concerned, the data key is just, so I haven't put that, blobs of random data. So the KMS doesn't understand your data key. From their perspective, it's just a blob of data. That's it. But what should be remembered is the data key will be in plain in your application memory, and the execution of any cryptographic algorithms like ciphering, deciphering, marking, whatever you need, RSA or EC or AES, will be in the application memory. So if you have security constraints that says no, it all has to be done on HSM, it's not going to work. But not all of the application have. And if you want to cipher the address, for sure you can do that, right? It's not some kind of a data that's so sensitive that you have to use an HSM for that directly. And obviously the data keys, because it's a blob, you can do anything with it. It can be EC, it can be RSA, it can be triple DES, whatever you need, like, or is being required. So how does it work? So the EC2 application connects to an KMS instance. It uses the CMK, how it is being used, and how it is being authorized. I have a slide about it later. You have a database and you have your data. And the idea is that the KMS generates deciphers, wraps on wraps, basically, your data key that you put in a box, in a wrapped form, into your database as well. And then the application does the ciphering and deciphering of the data with your data key. So it's a different model than we typically use, at least have been using since 2015, where basically we delegate all of the security for all of the data to HSM, and we don't give, let's say, a second thought about it. But once you are in the cloud, at least go look around what the other people are doing with it. And if you really need an HSM, and if you really cannot, for instance, use this technique, and we have been able to pass PCI DSS certification with just this technique, right? So we haven't been using HSMs to cipher our data. So it works, kind of, from a security point of view for this specification. It should work for the GDPR, it should work for PCI DSS. There is no need for an actual HSM. Still the security, let's say, infrastructure, the key hierarchy and the whole thing can be used. So how this AWS KMS works, so this has the CMK. I already told about it, but what I want to divert your attention to is that you will have data, and this data is typically in this context, which is those association with the other things like, I don't know, maybe you want to partition your data, you want to regionalize your data, you want to split your data into parts between two different types of entities or to the tenants, basically, and you would like to use different data keys for any combination of those four things. You can think about some other, let's say, variants and some other variability of your data key, but your data key should be basically different for every combination of those four attributes. How to do that? So that context, which comprise of those attributes, should be put into AAAD, which is called by the KMS as an encryption context. And this encryption context to any kind of a generation, wrapping or unwrapping function on your data key will be used as an authentication, basically. If this part of a system or this tenant has an access to this data key to decipher the other tenant data. So it should not, obviously, because if the context is different for your data, you should use a different key. So it's a kind of a security mechanism additionally built into to make sure that you use the data key in the correct context. And obviously then the ciphering and the deciphering of the data is being done with a data key. So if you look at from the typically checklist of the management strategy for your keys, the keys must be protected against unauthorized access. Data keys are ciphered with CMK, so the CMK is being properly guarded. Keys must not be stored with data. This, for me, was one of the, let's say, least addressed items, because if the data keys wrapped are stored, near to your data, like in the same database, does it let's say, comply? But the argument is that the keys are stored and wrapped with the CMK. So if you don't have a CMK access, it doesn't really matter. But we basically store it in a separate key space, let's say, to make sure that this item is addressed at least this way. The data keys are generated per context, so per entity type, service instance, partition of a system or a region. So keys, and this satisfies the single purpose requirement. Keys must be periodically rotated. So, and this is the extreme, because when you typically think about the key rotation, you typically get stressed, like, okay, I have to rotate the keys. Now, how to do that? So instead of, worrying and going against the requirement and saying, okay, I'm going to rotate it every 99 years. Well, does it satisfy the requirements? The other technique is just to generate the data key as frequently as you really need to, store them near the data and just forget about those. Like those are, in the extreme case, going to be once per record or once per entity. You can cache those to, lower your bills and not use so many data keys, but generally you can generate your data keys like every 1 minute if you want to, on every instance of your system, for every tenant, for every region, for every partition of a system, for every entity type, and you can have 100,000 of them, no problem, let's say, and store them in your database. And you can also force the technique that they will be regenerated, for instance, let's say every 1,000 or 2,000 or 30,000 messages or records. So this is the extreme case, but it certainly does satisfy the rotation and, let's say, restriction of single key usage requirements. Now, how to authorize the access, I'm not going to talk a lot about it, but typically you have this question, okay, so what was the first? Well, now we have a CMK, now how to protect the access to CMK? The answer is that there is so-called EAM role that you can assign to an EC2 instance via some service called instance metadata service that gives you that role via collaboration with a session token service. I'm not going to go into details. I have a short time to do that. So the effect is that on your EC2 instance, there is no password. There is no secret. There is nothing that the attacker could use in some other context, on some other place on the network, because this EC2 node is directly, let's say, authenticated and authorized by the security infrastructure of AWS to use the role which is entitled to use the particular CMK keys with a particular operation. For EKS, it's similar. It's a little bit more complex. I'm not going to talk about it, but it's also possible to do that, and you shall do that, obviously. When I'm talking about the secrets, it's not only keys. Sometimes you need to have those passwords, right? Database passwords. I don't know. You have a service. You need to store the credentials to this service somewhere. And here comes the security manager, AWS answer to do that. And actually underneath, if you already understand how the KMS looks like and how it works and what is the CMK, you will find yourself at home using the secret manager, and you feel at least at home that whatever secrets you put there, what it does really is that generates data key that is being protected with the CMK that you select or generated for the secret manager. And any kind of secrets are going to be secretly stored in the storage of a secret manager, but there will be no passwords in your files. Application has to, in runtime, access the secret manager service via IAM role, and it will obviously read a password from a secret manager instead of a file, any kind of a configuration file. So passwordless, let's say, solutions for the win. Now, if we are going to talk about the protection of data, it's not finished. I mean, the KMS is not an answer to everything. You still have to make sure that you are being protected on the network, in a database, and in a process. And when you are addressed, you have to remember that address doesn't mean only database. It is also about logs, about backups, about files. But also you have a responsibility on the application itself. The Alice Bob is typical names used in the security, let's say, diagrams. So I'm not going to use any. Service A, Service B, maybe a separate, better name. So the rest of protection is boring, so I'm not going to talk about it. AWS offers address protection in virtually all services. I haven't been able really to find any that doesn't. And underneath, either it's using some old custom techniques from the, let's say, previous version of the service, or it uses AWS KMS underneath to do that. And how it does it? Exactly the same as I described. Generates a data key. The data key is wrapped with the KMS, and the data key ciphers what needs to be ciphered. Is it going to be a database record or a block of the records, an extent in Oracle database? I don't know. S3 file or a whole bucket or a folder in buckets. Block on the EBS storage device, service, or the backup file, right? So the technique is the same. Underneath the KMS is your, let's say, single security source, the source of trust, source of security. The KMS is a guard for your CMK files, CMK keys, and from that, everything stems. And since I've mentioned that it's address protection by AWS, but still you have this application level security, which you still should take care of. And here you can replicate whatever we have been proposing previously, which is this model. If you are worried that you don't have a time, or you think that, okay, there must be a solution to that, there are proposed by AWS. So there is a DynamoDB client that offers the client encryption. And there is an S3 client-side encryption library as well. And there is AWS client-side encryption SDK, which has an integration to KMS, but it also offers other types of, let's say, keychains. So it doesn't have to use the KMS, actually. But it does what we just described about the management of data keys. You can look it up. You can see how it works. But you can use it in your application to make sure that your client-side data encryption works properly. Now, address protection obviously is also about other things I've mentioned, like logs, and about the logs. just don't store your confidential in the logs. I mean, mask it at least, right? Don't put it at all or obfuscate it. You don't have to use ciphering of the logs. I mean, logs can be ciphered by the S3 model, by the S3 service when not stored, addressed, but just don't put your confidential data at all because you don't have a control over those logs files typically. A lot of people are going to read those. And if you think that you are not doing a good job of not putting the confidential or, God forbid, sensitive data in your logs, then you can analyze your logs on S3 via a service called Amazon Macy that uses pattern matching and machine learning to detect the situation where, yeah, you made a bad job, and really it will alert you and tell you, okay, this log file does indeed contain something that looks like the phone number or the other data that you would like to protect. The second aspect is obviously network, and from the network layer, I'm not going to go into details since I'm primarily a developer or an architect, not a, let's say, network expert. But there are a number of techniques that you can obviously use for the network layer security. But still, I'm going to concentrate on an application level because this is what we have the most influence over. So typically, you want to instantiate something that is called end-to-end security model, where if you communicate with the other service, you want to be 100% sure that you are talking to the other service and there is no intermediate parties that decipher your data, make it available to someone else. You want to make sure that you keep two endpoints of that communication under the control. And whatever will be the techniques on the level 1, you can protect the network layer via different type of techniques. You can put a TLS, but still there will be some kind of a proxy, a DMZ, an SSL terminator, and the traffic on the rest of the network will be basically open. So if you terminate your TLS traffic on some kind of an ALB, on some kind of a TLS terminator, well, then your data is in clear then. It's no longer protected, and it's no longer confidential for the people that have an access to that part of the network. So obviously the third level is required when the service-to-service, process-to-process, application-to-application security is guaranteed, end-to-end model. So for the application level transport, what we have been using primarily is the JWE and JWS. Those are two standards based on JSON. And we just forgot about any other techniques than AES 256, keys with GCM for the confidentiality and integrity, and for when the external communication is involved, so between the systems, we additionally sprinkle that with a JWS, so we have a signature. But since the JWE offers confidentiality and integrity, the JWS purpose is not to provide the integrity. Its purpose is to provide the authenticity and the non-repudiation aspects. Therefore, if you have just the integrity requirements, you don't have to use JWS, just use JWE. That offers you those two things in a single package. And the transport keys, again, like a database keys, need to be stored somewhere, so you can store those in database files, but they will be, again, wrapped in CMK. Or you can even store them in Secret Manager if you really want to. So the JWE quick refresher, what I already told, I think that I will just confirm. JWS is not required for integrity, only for the non-repudiation and authenticity, so therefore JWE is sufficient. And all algorithms in JWE use this authentication encryption scheme, which offers the integrity as well, even if it's not AES GCM. If you are using some other combination like AES CBC, there will be a second HMAC function to provide the integrity aspect, so this guarantees that. So how the JWE, how to implement that? Let's assume that we are on this is the side of our service, and we have a client. The client would like to send us some confidential data over the JWE protocol. So first step is to generate the data keeper. Typically, that's the best thing. You may also sign it digitally with a CA, external one, trusted one. And then you send only the public key, obviously, to a party that would like you to send some confidential data. So this is a typical key exchange protocol. But instead of sending this public key over the email, exchanging via Teams, Skype, whatever, what is being typically done, and what we see that the industry or the internet goes, the direction it goes to, is just to use so-called well-known location for the JWKS file, where the public keys and their certificates, if you are so inclined to, can be just served. So the client will just basically access the HTTP and fetch your public keys and certificates that you are using for different purposes. Then it will be generating content key, asymmetric, typically ephemeral one that is just going to cipher your data. Then this whole thing will be sent back to your service where you can basically decipher your content key with your private key and the data and so on and so forth. So this model is what we have been using to, let's say, exchange the data between the external parties. So two aspects covered: database and storage and the network. And the last one, but not the least important, I would say that even more important, is to think about what if the attacker, this evil Eve, is already inside your process. How to protect against, let's say, break-in when it's not about network, it's not about the database, it's about your process, somewhere gaining the SSH access to your instance, right? How to do that? So the obvious concept is to make sure that you are inside, you have a container of some kind that you isolate your secure processing of your confidential or sensitive data into a secure area. And that's concept that we actually know from our DCs. We have the concept of these high security areas where we do concentrate our secure processing. And the same concept applies here, but it can be achieved in a different manner. So first obvious thing is to separate the service where you do the secure processing from the other services on the network within the same subnet. That will be the first step, and put a security group around it so it cannot escape, so it cannot access the internet, and no one else except for the service A, which is entitled to use that secure processing, can access that. That would be the first approach. The second approach would be to go and say, okay, I have the same subnet. Why not split it into two subnets, right? And put a network ACL there in addition to secure group. I mean, better say that, sorry, security is multi-layering concept. So you have to put multiple layers. That subnet will not have an access to your internal gateway. It cannot be accessed from the outside. It can only be accessed from the specific services running in a specific other subnet, and it cannot go outside. So you obviously can create the same kind of environment that we have in our HSA, which is a DMZ zone. So you can put an intermediate subnet that has an access from both sides, but it will be kind of a broker between those two subnets. I haven't put that diagram. It will be kind of an obvious, what you can do. But once you are at it and you have those private subnets, separate subnets, then why not put it into separate VPCs and make sure that you have a proper firewall for one of those VPC and the second doesn't have at all the internet gateway, and put a VPC peering. There is another technique called VPC private link that also can be used for that purpose, but it has other, let's say, limits, and it's more involved technique. And while you're at it, why not put those VPC in separate accounts? So you have, let's say, separate IAM roles, and you have even more control over what this other part of the processing does. But you can also go, let's say, into security, let's say, deeper. Instead of putting the services as far as possible apart by separating them by multiple layers of security group, network ACLs, separate VPCs, separate accounts, and separate whatnot, separate, I don't know, what else can be thought of. There is another aspect, like numbers go from 1 to infinity, but there are also numbers that go from 1 to 0, and so there are fractional numbers. So this is the idea that you can, let's say, protect your assets, protect your processing in the EC2 in a way that allows it for the processing to be more secure. So you separate the secure processing in separate what is called enclave. That's actually a separate VM process that runs on the hypervisor in your EC2 host. But it doesn't have any kind of a connectivity to an outside world, except for this virtual machine socket. So the hypervisor facilitates communication between those two virtual machines. It doesn't have any kind of a networking except for this Unix socket, and that's it. So in order, for instance, to communicate to KMS, which you typically think of, okay, how I'm going to do anything useful with that? I need to have an access to my keys. So the technique that is being proposed by the AWS is to put a KMS proxy there that is accessible via this socket, and this secure processing then you can use your CMK files. Now, obviously, Eve can interfere with our, let's say, idea and try to attack the proxy. So you have to find a way how to make sure that only this enclave and only this secure processing can access your CMK. So no person in between attacker in between can access your data and try to decrypt the traffic or access the CMK. So the idea is that there is an attestation, and the attestation is hardware-based. And the Nitro hypervisor provides actually not hypervisor, Nitro system provides the attestation. The attestation is basically a proof that this instance is secure, that it's a Nitro enclave, and I will talk about it in a couple of slides later, so that KMS can actually, authenticate and authorize the access to your CMKs only for that particular enclave, which is a quite powerful concept in the sense that nothing else can access your CMKs, and you can be sure about the security of your solution. So what are the other advantages of AWS Nitro Enclave? So one can write normal applications like using cryptography. The KMS is integrated via this attestation. Isolation is on a hypervisor level, so you would have to escape your VM, EC2 VM, which is already pretty hard, impossible, as far as I can tell. Images can be smaller and more hardened since you are in a very, very controlled environment. There is no network, there is no file system that you can write to. Basically, everything is very, very isolated. There will be no SSH of any kind or anything like that. It's stateless, doesn't have no persistence. There is an image only, and the only possibility to access it is via this socket. So the application kind of decides what it will talk to and over what protocol. And the application for the Nitro enclaves is obviously the kind of a sensitive data processing that we typically deal with. In a SRC system, I'm expecting a question, have you been using that? No, the Nitro enclaves were introduced past, let's say, the time that we initially carved out, let's say, large pieces of a system. Therefore, we haven't been using enclaves for that, but I would give it at least a consideration. And the one thing that you can use in Nitro enclave, even if you are not using the Nitro enclave per se, Nitro system, is to use the inter-EC2 traffic that it can be, if your instances are Nitro-based, and you can look it up on the, let's say, page, on the AWS documentation, because EC2 Nitro is based on hardware, it can do network speed encryption and decryption. Therefore, you don't pay a price for additional security between your EC2 instances. So you have those VPC peering security groups and whatnot, but this traffic is basically, okay, it's within, let's say, your AWS network, but if it's on a Nitro instance, you have a kind of a EC2 to EC2 connectivity guaranteed by the hardware that's inside these Nitro instances, and it can do the acceleration of the network ciphering and deciphering on the hardware level. There is also an interesting application for the TLS terminator in enclave, and I think that one that can be missed by you, and so I would like to highlight it, is some high-value intellectual property argument. So think about it like this. If you have spent, let's say, a lot of time designing your application, or even spent a lot of resources like GPU resources to train your neural networks, you want to run it in a so controlled environment that it doesn't escape. I mean, it's not leaked. Your spies from the other companies cannot steal it and use it for their own purposes without investment that you've made. I think that some of our algorithms can be seen as such high value algorithms and could be run in such enclaves. I think that's an interesting concept, even if we are not strictly talking about processing sensitive data, but typically those high value algorithms deal with sensitive data, so it's a good match, I think. So the secret sauce is the PCI Express card that is running here on the Nitro instances, and it does those attestations, and it's properly protected and FIPS certified on the level, I think, 1. The level 2 is probably something that they aim at some areas, but it's not an HSM in a sense that we can use it, like this enclave can really use that. The only 2 functions that are available is generate a random number, so it's an entropy source for your Nitro enclave, and the second aspect is that it can do the attestation of your Nitro enclave. And that attestation works like this. So you have the Nitro enclave, you generate the key pair using the random entropy that's provided by the security module via IOCTL. So it's a device on your let's say, enclave. That is being signed by the private keys of the security module. The private keys obviously are being signed by the CA, and you have the actual chain. And the KMS can verify and check access if this attestation has been provided by correct security module running on the correct hardware. It can do much more than just verify if the signature is correct. It can look into the attributes of attestation. It's not only public key that is being put here, the public key of your enclave, but also there are other attributes. Then it can do any operation on data key using the CMK wrapping and wrapping generation. And then typically it ciphers the resulting data key with your public key of your instance. Therefore, the only enclave can decrypt it, right? Using the private key of the enclave. So it's a kind of an end-to-end security mechanism for exchange in the AWS KMS between the enclave and the KMS. And this mechanism is only available to enclaves. It's actually not visible if you look at the KMS API. It's not visible. How did they do that? You have to go really, really deep and find that there are extensions to KMS API that allows this model to work. And what attestation contains, I already mentioned a couple of things. One is public key, that's one thing. Some user data, different hashes, checksums, start times, timestamps, the role of the parent instance, digital signature, obviously at the end of the Nitro hardware that signed the attestation. So it's a very, very nice solution. And I would also direct your attention that the attestation become more popular. For instance, we just, yesterday, released an SDK version, which is for Android. I have a slide about it, sorry. Actually, if you look at it, maybe Konrad said, oh, I know this model, I see the attestation. Yes, the attestation is the way to go if you have if you want to strictly secure some environment. And on Android, hardware attestations using TE or the Strongbox, maybe they are not that strong. I mean, in the sense, comparing to a dedicated PCI card running on your EC2 host. But it does exactly the same things. It scraps the data of your, let's say, application, gets the digital signature of the developer that signed the application, gets the image hash codes. There's a lot of information. And then it's signed it with the private keys of your, let's say, key store. That is obviously signed by the OEM keys, that it's signed by the Google keys, and you can verify that all on the server, and you can be pretty sure that if you are talking to a mobile device, at least some of the keys that were there, or at least the application that were deployed there, were somehow attested, verified by whatever the security the device has, but it will be hardware security, either based on the ARM-TE model or the Strongbox, which is a separate secure element, I guess. It's available since Android 7. So I've run out of time, so I will finish my presentation here. Okay, it wasn't me. I was having a couple of slides about Cloud HSM, but I will have to finish here on the Q&A, if there are any. We have a long break, I believe, right? Okay, that's it. Thank you very much.